Awesome. Thank you so much. Thanks for having me. Super excited to be here. So my name is Arni, and I'm a game tech developer advocate for AWS. That means that I do a role where I kind of go to conferences, I talk to customers, I tell them about game tech, how that works, and and my focus is game tech specifically. So I've been with Amazon for 3.5 years, and for most of that time I've been a solutions architect, actually focusing on games customers. A little bit of startups as well. Prior to joining AWS, I worked for a company called Plain Vanilla Games on a game called QuizUp, where I was an infrastructure lead, and that was a game that was fully run on top of AWS and kind of naturally led me then to working for AWS. I'm based in Stockholm myself, although I'm originally from Iceland, so maybe you recognize my harsh Icelandic accent, similar to Björk and Eyjafjallajökull, another famous items from Iceland. So today I want to just talk a little bit about what game tech is, and maybe start a little bit with the state of the industry, kind of what's happening. I want to talk about a little bit how games are different from many other types of workloads. So what are the kind of specific challenges and requirements that games have that for example, web applications don't necessarily have? And so what are the typical challenges that the games companies are dealing with? Then I'll talk about game tech. So what is game tech? And then some of the services that we have within game tech, such as GameLift and Fleet IQ. And I wanted to also talk about a game analytics pipeline solution that we have recently published. So I know that you have already covered on these meetups some analytics, so perhaps I won't dive very deep into it, but I want to tell you about it. So that's the idea for my talk. So the games industry is really growing. It has been growing for a while, but it's really growing. And just to kind of get a sense for it, if you look at the global games market report from Newzoo, the games industry revenue globally is forecasted at $159 billion in 2020. It's an extremely high number. But just to put it into context as well, they also forecast the number of mobile games players globally to be 2.6 billion. So that's a large portion of the population of Earth. And to also put the numbers into context, if you compare this to the film industry, for example, the entire global film industry box office revenue, so the box office revenue in 2019 worldwide was 42 billion. So it's less than a third of what we expect, or Newzoo forecasts this to be in 2020. So games are becoming an incredibly large industry, larger than many people know. And games are also evolving, and they're bringing a lot of new challenges. So first of all, there are new monetization models, right? We're moving away from this typical, you buy a game, you get it in a box with a CD and so on. We're moving into it's free-to-play games, it's ad-based revenue, there's subscription models popping up, obviously downloadable content, like being able to extend the game after you've bought it. And even Kickstarter campaigns that are funding new games and so on. So there's a lot of kind of new ways of monetizing games. And there's also a new set of consoles coming, right? There was the PlayStation 5, the Xbox Series X, and so on. And these are even more powerful than before, which brings more data, more assets, more complexity. Games are obviously getting kind of more connected, more social, more dynamic. It's rare to find a game where you're kind of isolated to yourself. And in fact, you could almost say that the games are becoming like a games as a service model, very different from what it was a few years ago. Games aren't developed, burned to a golden master DVD and then shipped off, and then you kind of go and work on the next game. It's very much expected that games evolve over time, and that the weapons and items in the game are continually balanced to make the game fair and to make it fun and exciting. New features to be added, and so on. So it's not a fire and forget. And this is what is quite often called live ops today. So from a cloud perspective, or from a cloud computing perspective, by the way, my slides, they're moving, right? Never really trust these. Do you see what's special about game slide?
Yeah, that's fine.
Perfect. Perfect. And so from a cloud computing perspective, or from even like an infrastructure or backend perspective, what's special about games? Like, what are some of the challenges and requirements that games have? And so the first thing we can mention definitely is networking. With all of this kind of additional content that's available for download, all the social interactions, the live streaming of games for others to watch them, distributing large updates to games, there's increasing requirements for bandwidth all the time. And at the same time, real-time multiplayer games require really low latency. You have to have a very good connection. You have to be playing with servers that are kind of close to you. And for those kinds of games, actually, you usually have to deal with two different types of protocols, both a UDP protocol and a TCP protocol. And the reason for that, and if you're not aware of it, UDP protocols are a much simpler protocol. It has a much smaller header. It doesn't do a three-way handshake. It doesn't do any retry. There's no retry mechanisms and so on. It's very much kind of a fire and forget protocol, and it's used because it's quicker to send packet updates that way. And packets can be delivered out of order. They can be dropped and you wouldn't really know about it. But if you think about it, if you're playing a real-time game where you're sending like your actions or your position or where you want to move or what you want to do, actually if a packet gets dropped, it probably doesn't make sense to resend it, because at the time when it's resent and kind of received again, it's already outdated information. So you'd rather have a very quick way of sending packets and then just drop and kind of figure it out if that happens. And then for all of the things that you want to be a little bit more reliable, so things like posting your score after a game, or checking out the leaderboard, or requesting a match, sending a message, those kinds of things, that typically goes over TCP, and it also typically goes over HTTP. So it's typically more like an API as you would see normally. So games typically have to deal with kind of both of these layers. And this is what I find actually to be interesting. This is one of the few places kind of where I find myself hitting the laws of physics on a daily basis. So I'm sure you all recognize the number on the screen. 300,000 kilometers per second is the speed of light. And it's the fastest speed that's possible to achieve, at least as we know right now. And it sounds like a speed that's almost impossible to even grasp, to even really understand what that number means. For example, the Earth is 40,000 kilometers circumference, which means that every second, if you could travel at this speed, you could go 7.5 times around the Earth per second, right? So it seems like an enormous number. But the thing is, it's not really, because if I would want to send a packet, let's say from Stockholm, where I live, to New York, that's 6,321 kilometers. And if you just do a simple math, you just measure how long does it take, even if you're traveling the very shortest distance possible, line of sight, cable from my house to New York, that still takes 21 milliseconds at this speed. And by the way, network packets do not travel at this speed, and there's no direct line from my house to New York, right? So this is the fastest theoretical possible time to send the packet between those two locations. And that's one way. And if I'm going to send a ping, for example, I'm going to send an update and get a response back, then it's 2 times that, and it's 42 milliseconds. And if you're doing a TCP handshake, like a three-way, send a SYN packet, get an ACK, or SYN ACK, and you send an ACK back, that's 3 times this number. And then you do SSL negotiation on top of that if it should be encrypted and so on. So this is where you really kind of see the limitations of physics. And again, to be able to play competitive games in real time, you need a latency that is somewhere kind of in those ranges. It's often said that anything kind of above 100 milliseconds is quite bad. Although some games can cope with it, and it's different between different games. And in other games, you'd like to have this below 30 milliseconds or 50 milliseconds to be really kind of playable in a nice way. So what does that mean? That actually just brings us to one of the requirements of games is really to have a global infrastructure. You need to have game servers deployed all around the world, and you need to have measures in place that make sure that the players connect to a game server that is close to them, and preferably along with their friends, right? You want a group of friends to play together or play against another team, and they should be connected to where they get the lowest latency. Scaling is another another huge technical requirement. Being able to scale is essential because the infrastructure requirements for games often goes like a tenfold. The magnitude is kind of tenfold often between the lowest points of the day or of the week to the peak. And players also, they follow the sun, right? So as you kind of start scaling down in one part of the world, another part of the world is scaling up because the players are waking up there and they're going to sleep somewhere else and so on. There are also other peaks like weeks versus weekends, there's vacation periods and so on. So it's crucial to be able to scale. And interestingly enough, games are almost never stateless. So if you think about compared to a web application or something like that, where you can have stateless sessions, or you can store state in a Redis or Elasticache or something like that. With games, typically you have to have the state in memory available on the game server where you're playing to be able to calculate the physics and where things are going and so on. So the state essentially stores where you are relative to everybody else. Who can see who is attacking who, what's people's health, lives, and so on. And so if you think about it, if you're running game servers in a number of regions, let's say that you have these two regions here, region A and region B, and you have game servers in both regions, and you have some people that are connected into them. Because these servers have state, you have to be a little bit more clever about how you can scale. As you start seeing less load, so in the picture there's only a couple of people kind of playing in region B, but they are playing on all of the servers. And so therefore you cannot really shut down any of the servers. So it's hard for you to scale down, even if the load in that region is quite low. And that essentially means that we can't really scale up and down based on CPU only, or the typical kind of load metrics. You have to look at, if you look at the right region there, it only has this handful of people playing. The load is really low. But since there are people playing on every server, they have state, we can't really shut them down. We don't want to disturb them, we don't want to disconnect them, and so on. Essentially what we need to do is we need to scale our systems up and down based on sessions. So how many sessions can each of our game servers run? So how many kind of groups of players can be playing? And then in each of the sessions, how many people are playing? And that's kind of how you usually look at scaling for these. And then when you're taking decisions on scaling up and down, you typically have to do that based on the number of kind of free slots that you have. So assuming that a new stream of game requests is coming in, new people want to play, we want to have a set of free slots available for them to take and be able to play there. And as that number kind of gets lower, that's when we add more servers, obviously. And if that number is pretty high, then that means that we probably can get rid of some servers and start scaling down. So we don't really scale that often on CPU or the typical performance metrics, but rather on the players that are playing and the sessions that are being played. One of the ways to do that is to use auto-scaling groups. And essentially using instance protection or something like that. So you monitor like which instances have games that are being played on them, and you enable instance protection on those instances. So even if the load is low or there are too many free slots, we will still wait with shutting those instances down until you remove the instance protection. You would also probably have to be a little bit more clever about how you place people on servers. You would want to kind of earmark a server for removal and then stop placing new sessions on it until that completely drains out, and then you can remove it, right? So you need to be a little bit more clever. So are there simpler ways of doing this? Absolutely, I'll get to it a little bit later. So just to kind of give you an example of scale, I wanted to tell you about Epic Games, which is one of the kind of all-in customers on AWS. Their game, Fortnite, including the worldwide game server fleet, the backend services, databases, analytics, it all runs on AWS. And they see peaks in usage that are more than 10 times their kind of non-peak usage. And occasionally they run events where they invite all of their 200 million users to participate in the events. So they have to be able to scale. So other typical backend workloads that we see from games companies. apart from obviously the multiplayer game servers that we talked about already, we see a lot of authentication, connections to third parties, connections to Steam, for example, saving progress in games. As you go along in your game and you achieve something, you want that to be kind of saved somewhere, and that's quite often in the cloud. If there's any kind of economy in the game, items to purchase or trade, verification of purchases, buying, selling, in-game stores, inventory management, and so on. Chat between players in your games, leaderboards, and more. And there's obviously analytics as well. And as I mentioned, I know that that's been kind of covered in these meetups before, so I'll only kind of dip my toes into that. Interesting thing to note is also, if you look at this list of different features and services, is that actually a lot of these are necessary whether you're running a multiplayer or a single player game. They're not all just for multiplayer games. So what is Game Tech? Like, how does that fit into this picture? Game Tech is a collection of all of the products across Amazon that offer solutions for every stage of the game development or the game's lifecycle, regardless of the studio size. And so that includes AWS obviously is one of the components where a lot of our games companies are running on top of AWS. There's also Twitch, there's Alexa for games, there's GameLift, and Lumberyard, which is a 3D engine that you can use to make AAA games. And the Game Tech solutions are across a wide variety of things. Anything from backend services like game server hosting, machine learning, analytics, obviously, developer tools, broadcasting via Twitch, engaging with your players, and so on. And the part that I wanted to dig a little bit further into today are the backend services and the analytics part. So first, before we dive into those, this kind of necessity to be able to have a global footprint is, of course, a key feature of AWS. So currently we have 24 regions that allow you to deploy game servers all over the world. In those regions, we have 76 availability zones, which I'm sure most people here know what that is already, but these are separate data centers and separate facilities within a region where you can have highly reliable, redundant workloads deployed. With 3 more regions announced, Jakarta, Osaka, and Spain. And for the edge services that we have, CloudFront and Route 53, and those we have a 216 points of presence in edge locations and regional edge caches and so on. And those are meant for, so CloudFront being our CDN, those are services that help you distribute content, distribute updates, binaries, and so on to your users. But if we look into game server hosting, you have typically 2 main options. Either you build it yourself, so you build it on top of EC2, or you might build it on top of containers running on ECS or EKS, or you can use our managed service, GameLift. So GameLift has a few features that can help you both save time and save money if you're getting started. And one of those things is the ability to use spot instances with a feature called Fleet IQ. So let's dig into these a little bit. Actually, the first comparison that we can also make before we start thinking about the cloud versus running on premises is that actually quite a bit of games have traditionally used peer-to-peer networking. So comparing dedicated game servers on AWS, we also need to compare it to peer-to-peer networking. And in peer-to-peer, that's where you don't have any backend, but rather when 2 people want to play together and you kind of matchmate them, they will, one of them will connect to the other. So one of them will act as a host and the other one as a client, and they will just connect to each other. So one of the issues there, first of all, is that then you're relying on home internet connections, and you don't have as consistent latency and network connectivity. Also, it's very hard for you to prevent any kind of cheating, because if people connect directly to each other, there's no way for you to see as the games company what kind of what's being sent between them, is somebody modifying the traffic or changing some of the data or something like that. So overall, you get better performance if you have dedicated servers. You can support larger number of players because you have bigger connections, access to bigger instances, and so on. And you don't have to deal with, for example, NAT, which is a typical issue as well. People have firewalls on their routers in their homes, and you cannot always connect through those to make a connection. And so GameLift is a service that helps you deploy, operate, and scale dedicated servers. And it's a managed service, and it's specifically meant for session-based multiplayer games where you want to kind of take a group of people, you want to make them up in a good way, and then you want to send them up to connect to a server to play. And GameLift provides you with low latency because you can deploy it into 15 regions around the world. And provides you with high availability because it auto scales the number of servers that you need and so on, and is very, very flexible. And when you're using GameLift, actually, I think I have an architecture diagram here. When you're using GameLift, your game clients will connect to your backend services, so to your game services, which is where they'll find like maybe the lobby of the game. They could maybe send some chats or do things like that, and they're not kind of actively playing a session in the game. So they're just connecting to your game services. As soon as they want to start playing a game, that's when they will be kind of connecting into GameLift first. And it starts with a part of GameLift that is called FlexMatch. FlexMatch is an optional service that you can use in GameLift, so you don't have to use it, but it's included and free if you want to. And it allows you to match make groups of people based on rules that you create. So the rules in FlexMatch could be things like, I want it to be 4 people in a red team versus 4 people in a blue team. So it's a 4v4 game. And maybe you have to have specific classes. Maybe there should be a wizard and a knight, or something like that. So you could kind of create those kinds of rules, and then you can also specify the level that people are on. So let's say the average level in one group and the average level in the other group shouldn't be too far away from each other. So you can create those rules, and everybody that's connecting into the game services, everybody that's being kind of put into the FlexMatch system will be matched up based on those rules. Now, sometimes it's hard to find a match. Sometimes you can't find another set of people that has the specific criteria that you want. So with FlexMatch, you can even have rules that expand over time. So let's say if you haven't found a match within 5 seconds or 10 seconds, then you say, okay, then it's okay to have a little bit more of a difference in level, something like that. So that's supported by FlexMatch, and it's basically a JSON-based document that you provide with your rules. So when a group of players has been matched up, they get put into a queue. And the queue is a service that will then route that group of players to the lowest latency region for them where there's an available server. And so all of the things that you see there in the GameLift section, everything that's pictured in that area, is managed and run by GameLift. And so it's not running in your own account in AWS. So these instances, you do not even see those instances. That's all managed. And the only thing that you provide to GameLift is a game server binary. So it could be a Unity binary, an Unreal server binary. It could be Lumberyard, or it could be a custom thing. So there are SDKs as well. And GameLift will take care of creating a server image, an AMI, the auto-scaling functionality, the groups, networks, routing, VPCs, like all of those things are taken care of by GameLift, so you don't have to know how to do that. And you can essentially deploy fleets into all the regions that you want to, up to those 15 that we support currently. You have a selection as well in terms of what kind of instances do you want to have there and so on. So, if you want to have a compute type of instance, you could go for a C5 family and so on. So that's GameLift essentially. So the cost factor here is something to consider. Peer-to-peer has one key advantage over any dedicated game servers, and that it's free. And so one of the things that we've thought about quite a lot with GameLift is how can we make sure that the cost of dedicated servers isn't too high. And so that's one of the focuses. And that's done in two main ways. One of the ways is that GameLift will auto scale using target tracking. So you can say, I want there to be a certain amount of slots available for people to play. And then GameLift will adjust and scale up and down in the different regions to make sure that promise is kept, or that they have the right amount of instances available. So you have this kind of full auto scaling that follows the curve. And mind this is based on player sessions, right? This is not based on CPU load or those kinds of metrics. This is based on how many players can play on a server and how many do we have currently and so on. The second thing that it does is it also uses instance packing. So if you look at the right side there, you can see that there are 3 instances, 2 kind of game sessions on one of them, and then one of each of the other ones. Actually, what GameLift will try to do is to kind of force these to be populating one server rather than being distributed across servers. And so this allows you to have those empty instances available, or have less underutilized instances, which also allows you to scale down when you need to. And so there is a study, I don't have a link here on the slide, but there's a study that says that compared to a typical kind of on-premise data center, usually those on average run at between 12 or 18% utilization, while this kind of system will run very close to a full utilization because you're always matching the resources to the demand. There's another thing that GameLift does to help you save on costs, and that's using spot instances with a feature called Fleet IQ. So assuming that you are mostly familiar with Spot, I'll give you a brief overview. Spot instances are compute instances in AWS that are unused capacity in our data centers. So we have our data centers, they're full of servers, and we want to make sure that those servers are all being used at all times. So whenever we don't have customers that are using those servers on demand, we offer them with a huge discount on what's called the EC2 Spot. Now, spot instances can give you up to a 90% lower price, depending on their availability. But they have an interesting caveat, and the caveat is that they can be interrupted, and they will get interrupted if AWS needs the spot instance capacity for an on-demand customer. So somebody's willing to run that instance on demand, paying the full price, then we will shut down some of the spot instances. When that happens, you get a 2-minute notice about it. So this obviously brings up a big question, right? How can this be useful for session-based multiplayer games where you are actively playing a game? You definitely don't want to be interrupted in the middle of a session, right? So that's peculiar. So the way that it works is that GameLift and Fleet IQ uses, let's say, a trick to find spot instances that have the least chance of being interrupted. So this can be done by various means. First of all, AWS publishes metrics around spot capacity that's available, right? So we publish the likelihood of spot instances being interrupted by their regions, availability zones, and instance families. And GameLift Fleet IQ consumes that information. And then they can, with that information, they can predict over time how they believe it's going to evolve. What they also do with Fleet IQ is that across all of the customers that are running on GameLift and across all of the customers that are running with Fleet IQ, GameLift can monitor which instances are actually being terminated by the spot interruption. And when that happens, it can mark those instances as don't use them for now, because obviously they are in that particular region, in that particular availability zone. They are not as available. And so combining all of this information and then utilizing it to make selections on which type of instances and where should Fleet IQ be starting instances. And so typically customers are using a combination of both on-demand instances and spot instances with Fleet IQ to be able to, when there's less spot available, to be able to kind of rebalance to on-demand. And with that, typically we see up to 70% cost savings compared to on-premises deployments. So that's really, really interesting. And there's actually a major update that just came out recently, which is that this feature of Fleet IQ used to be limited to GameLift. So you could only, if you were running GameLift game servers, then you could use Fleet IQ. But if you were running on EC2, or if you're running something that you built yourself, you wouldn't be able to use this functionality. But there's now a feature in preview where Fleet IQ is being kind of extracted out of GameLift, or made available to those that are not using the full feature set of GameLift. And that allows you to run your own auto-scaling group of instances in your own account for your own games, or combine it with an on-premises. If you're migrating on-premises game servers into the cloud, you can combine the two, and you can use the Fleet IQ kind of functionality and logic to help you pick the right instances at the right time. So outside of GameLift. Yeah, so last but not least, I wanted to talk about analytics for games. So how about analytics? Analytics in games is used for a number of different things. So first of all, it's used for live ops, right? Making choices, having the right data at the right time, being able to kind of balance games, to see if a certain weapon is more powerful than it should be, or a certain area of the game is more popular or less popular, and just kind of being able to see what's happening in the game and make modifications. It's also used a lot for monitoring. So being able to see, what's happening with the game, are people having connection problems, how's it going with matchmaking, and just kind of all kinds of monitoring of your game. And then obviously experimentation, right? A/B testing, being able to see, would this be a good change? Would that be a good change? And kind of testing it out and getting real data. And I'm sure you all know this customer, Supercell. For those that don't, they are a Finland-based mobile game developer that makes Clash of Clans, Brawl Stars, Heyday, Clash Royale. And they are also an all-in on AWS customer. They're using the platform to process more than 5 terabytes of data per day, which they ingest with Kinesis. And then they have over 600 databases and 5,000 servers across Aurora and EC2. The one thing that I wanted to talk about with analytics today is the newly released gaming analytics pipeline solution. So we used to have another gaming analytics pipeline. Yeah, probably we should call it a solution available, but that was getting quite outdated. So this is something that was released in May. And this solution was created by a team of solutions architects and technical account managers at AWS that work with some of our largest games customers on a daily basis. And they used the experience that they've gained from working with those customers to build a fully deployable analytics pipeline with CloudFormation templates. You can deploy them. You can get a fully functioning pipeline with those templates. There's also a deployment guide that kind of guides you through the setup. There's an included what's it called, like a generator to generate example traffic. There's also included sample queries to run through Athena and so on. So let's have a look at kind of what this looks like. This is something that you could start out, just deploy it, see how it looks, and you would be very, very quick to see some results from that. But you could also obviously use it as a base for what you need to build. So the solution includes streaming data ingestion using Kinesis, like most of the analytics pipelines that we see on AWS. It's automatically loaded into S3. It's converted into an optimized format in form of Parquet. It also includes custom real-time metrics, a SQL query using Kinesis data analytics, so SQL query support, a CloudWatch dashboard, fully integrated with a data lake, because all of the data is already ending up partitioned in a data lake in S3 in the right format and so on using Glue. And the solution also actually includes a guidance to creating a quick site dashboard to see what it looks like. See what your data looks like. So this is the full reference architecture that is being deployed in that solution. It's quite a lot of things, but interestingly to note here that this is a fully serverless analytics pipeline. So that means that if you deploy this, there are certain components of it, such as CloudWatch metrics and Glue job. And there are certain things that will have some running costs, but this is something that will scale down to very, very low cost, and it's easy to experiment with it, even if you're maybe just starting out making a game or something like that. So it doesn't deploy a whole lot of big servers, for instances. Yeah, I'm not not sure if I should kind of go through the whole pipeline. I'm sure you've seen multiple pipelines like this before, but essentially if we start on the far left, you have the data producers, so like the game clients, the mobile clients, servers, backends, whatever you want to stream information from. And they all push information into a Kinesis data stream, or they go through an API gateway if you want to authenticate the traffic. So quite often your game servers will be allowed to push traffic directly into the data stream, while game clients would have to be authenticated before they do that. So they could go through the API gateway to be authenticated there. That traffic is then split into both a streaming analytics part, which is on the, wondering if I can use my mouse here. So it goes into a streaming analytics part, which has a Kinesis data analytics stream, which is then which executes a Lambda function on the incoming packets or incoming data, and then that's pushed to CloudWatch for a dashboard and having metrics. The stream is also pushed through a Kinesis data firehose, which will take the data, move it into S3. It will transform it on the way using Lambda. And when it's in S3, a Glue ETL job will pick it up and convert the format and kind of re-partition it. And last but not least, kind of the lowest layer there is, first of all, there's a configuration endpoint where you can, for example, add new games that should be allowed to send things into the pipeline, which can be configured through that endpoint. And on the far right, or the right bottom, there's a lot of components in here. That's kind of where you will then visualize the data. So using Athena to make SQL queries directly into S3, and connecting QuickSight, which is our BI tool, to be able to create dashboards, graphs, things like that. So pretty full solution that is a great starting point if you're interested. I have no idea how I'm doing on time, but that's all I had for now. And I wanted to point out that I'm running a webinar series between 22nd and 25th of June, where I'll be diving into both analytics, backend game, server hosting, migrations, and lost my thread there. But it's four different sessions over 4 days, one per day. If you're interested, then please sign up and join me there as well. I'll give you a second